Chapter 9, consider business intelligence or BI system. BI is an information system that identifies pattern, relationship, and other information from organizational structure and unstructured data, external and purchase data. In the first dialogue of Chapter 9, Dr. Flores is talking to Maggie Jensen, one of the information system professional who is developing the PRIDE system about 1. A practical application for business intelligence system, specifically reporting. 2. Show the use of animation for reporting on a mobile device. 3. Provide a setting to teach standard reporting terminology. Study questions. Question 1. How do organizations use business intelligence system? Question 2. What are the 3 primary activities in the business intelligence process? Question 3. How do organizations use data warehouses and data marts to acquire data? Question 4. How do organizations use reporting application? Question 5. How do organizations use data mining application? Question 6. How do organizations use big data application? Question 7. What is the role of knowledge management system? Question 8. What are the alternatives for publishing business intelligence? Question 9. MIS in 2024. The information system described in Chapter 7 and 8 generate enormous amount of data. The system in Chapter 7 generates structured data that are used for operational purposes, such as tracking orders, inventories, payable, and so forth. These data have potential windfall. They contain pattern, relationship, and cluster and can be used to classify, forecast, and predict. Social media data from systems discussed in Chapter 8 are unstructured, but also provide the same windfall. However, there is so much social media data that end result in big data collection which needs specialized processing. This chapter consider business intelligence or BI system, which are information systems that can produce pattern, relationship, and other information from organizational structure and unstructured social data, as well as from external purchase data. In addition to this data, another rich source of knowledge is employees themselves. Employees come to the organization with expertise, and as they gain experience in the organization, they add to that expertise. Vast amount of collective knowledge exists in every organization employees. The question is, how can that knowledge can be shared? Business intelligence systems are information systems that process operational, social, and other data to identify pattern, relationship, and trend for use by business professionals and other knowledge workers. This pattern, relationship, trend, and prediction are referred to as business intelligence. As information system, business intelligence systems have the 5 standard components: hardware, software, data, procedure, and people. The software component of a business intelligence system is called a business intelligence application. In the context of their day-to-day operation, organizations generate enormous amount of data. According to McKinsey & Company, as of 2009, companies with more than 1,000 employees in nearly all sectors in the U.S. economy had at least an average of 200 terabytes of stored data. Business intelligence is buried in that data, and function of a business intelligence system is to extract it and make it available to those who need it. The boundaries of business intelligence are blurry. In this text, we will take broad view shown in Figure 9.1. Source data for business intelligence system can be the organizational own operational data, social media data, data that organization purchases from the data vendor, and employee knowledge. The business information application processes the data to produce business intelligence for use by a knowledge worker. As you will learn, this broad definition encompasses reporting application, data mining application, big data application, and knowledge management application. As shown in figure 9.2, business intelligence is used for all four of the collaborative tasks described in Chapter 2. Starting with the last row in this figure, business intelligence can be used just for informing. Moving up a row, some managers use business intelligence system for decision making. Some authors define business intelligence system as supporting decision making only, in which case they use the older term decision support system as a synonym for decision making business intelligence system. We take a broader view here to include all four of the tasks in figure 9.2 and will avoid the term decision support system. Problem solving is the next category of business intelligence use. A problem is a perceived difference between what is and what ought to be. Business intelligence can be used for both sides of that definition. Determining what is as well as what should be. Finally, business intelligence can be used during project management. As you study in this figure, the hierarchy of these tasks, deciding requires informing, problem solving requires deciding and informing, and project management requires problem solving and deciding and informing. Figure 9.3 shows the three primary activities in the business intelligence process: acquire data, perform analysis, and publish results. Data acquisition is the process of obtaining, cleaning, organizing, relating, and cataloging source data. Business intelligence analysis is the process of creating business intelligence. The four fundamental categories of business intelligence analysis are reporting, data mining, big data, and knowledge management. Publish result is the process of delivering business intelligence to the knowledge worker who need it. Push publishing delivers business intelligence to user without any request from the user. For example, the business intelligence results are delivered according to a schedule or as a result of an event or particular data condition. Full publishing requires the user to request business intelligence result. Publishing media include print as well as online content delivered via web server. Specialized web server known as report server. And business intelligence results that are sent via automation to other programs. Figure 9.4 illustrates some source table from operational databases and some new tables created by Lucas and Edison. Figure 9.5 shows sample data from the item summary table. To determine the extent of sales loss due to short shipment or damage, Edison created an access report, see figure 9.6, to some data from item summary data table. From this report, she can see that vendor 5,000 and 2,000 have never had a shortage or quality problem. Vendor 4,000 has a modest problem, but vendor 1,000 and 3,000 have caused numerous lost sales, either to shortage or damaged good. In fact, more than half of the sales of vendor 3,000 items have been lost, or 19,450 out of 35,000. To find out if these lost sales are due to one or two events, or if they represent a recurring problem, Addition creates the report shown in figure 9.7. From this report, they can see that vendor 3000 problem, although not substantial, are primarily due to one problem on even item number 600. However, vendor 4000 has a regular pattern of shortages or damage, or both. To learn this problem, Addition creates more reports. Figure 9.7 shows item by even item number and not by item name and even date. Figure 9.8 shows a Microsoft Excel data that has even data, including vendor and item names. These two figures present some problem. For example, if the Microsoft Excel were in tabular format, it would be easy to import this data from Microsoft Excel to Microsoft Access. However, it is not, and someone must go through this spreadsheet and either put it into tabular format or extract data from the spreadsheet and manually enter it into the Microsoft Access database. This situation is typical of the kinds of data conversion and integration activities that business intelligence requires. To find out how many of the lost sales are due to short vendor shipment and how many of due to damage, Addition produced the report shown in figure 9.9. In that figure is shown that all of vendor 1000 problem are caused by damage. That vendor always ship the appropriate number. The damage could have occurred as the result of catastrophe to a single shipment, or it might be a persistent damage problem. To check out the possibility, Addition prepared the report shown in figure 9.10. From this report, they determined that vendor 1000 has persistent damage problem. Addition and other buyer can use this knowledge when negotiating with that vendor in the future. Sometimes, business intelligence system produces inconsistent report, such as discrepancy is not unusual for business intelligence analysis. When data are integrated from several or many different sources, the resulting collection is frequently inconsistent. The only safeguard against inaccurate analysis from such inconsistent data is for the analyst and knowledge worker to know that such inconsistencies are possible, to be on lookout for them, and to apply a critical eye on business intelligence result. There are several possibilities to publish business intelligence result. For example, 1. Print and distribute the result via email or collaboration tool. 2. Publish via a web server or SharePoint. 3. Publish on a business intelligence server. And 4. Automate the result via SOA service. Although it is possible to create basic report and perform single analysis from operational data, this method is not usually recommended. For reasons of security and control, information system professionals do not want business analysts like Addition processing operational data. If Addition makes an error, that error could cause a serious disruption in organizational operation. Also, operational data is structured for fast and reliable transaction processing. It is seldom structured in a way that really supports business intelligence analysis. Finally, business intelligence analysis can require considerable processing. Placing business intelligence application on operational server can dramatically reduce system performance. For this reason, most organizations extract operational data for business intelligence processing. For a small organization, the extraction may be as simple as an Access database. Large organizations, however, typically create and staff a group of people who manage and run a data warehouse, which is a facility for managing an organization business intelligence data. The function of data warehouse are to 1. Obtain data, 2. Cleanse data, 3. Organize and relate data, and 4. Catalog data. Figure 9.11 shows a component of a data warehouse. Program read production and other data and extract, clean, and prepare the data for business intelligence processing. The prepared data are stored in a data warehouse database using a data warehouse database management system, which can be different from the organizational database management system. For example, an organization might use Oracle for its operational processing, but use SQL Server for its data warehouse. Other organizations use SQL Server for operational processing, but use database management system for statistical package vendor such as SAS or SPSS in data warehouse. Data warehouse include data that are purchased from outside sources. The purchase of data from other companies is not unusual or particularly concerning from a privacy standpoint. However, some companies might choose to buy a personal consumer data, for example, marital status, from data vendor such as Axiom Corporation. Figure 9.12 lists some of the customer data that can be readily purchased. An amazing and frightening to know the type and amount of data that is available for sale. Metadata is data concerning the data. For example, its source, its format, its assumption and constraint, and other facts about the data is kept in a data warehouse metadata database. The data warehouse database management system extracts and provides data to business intelligence application. Most operational and purchase data have problems that inhibit their usefulness for business intelligence. Figure 9.13 lists the major problem categories. Problematic data are termed dirty data. For example, a value B for customer gender and of 213 for customer age. Other examples are a value of 999-999-9999 for a US phone number and an email address of yme@guesswhoiam.org. All of these values can be problematic for business intelligence purposes. Purchase data often contain missing elements. Most data vendors state the percentage of missing value for each attribute in the data they sell. An organization buys such data because for some uses, some data are better than no data at all. This is especially true for data items whose values are difficult to obtain, such as number of adults in household, household income, dwelling type, and education of primary income earner. For some business intelligence application, a few missing data points can seriously bias the analysis. Inconsistent data is particularly common for data that have been gathered over time. For example, when an area code changes, the phone number for a given customer before the change will not match the customer number afterward. Likewise, part code change, like part code for sales territories, Before such data can be used, they must be recorded for consistency over the period of the study. Some data inconsistencies occur from the nature of business activity. In case of web-based order entry system used by customers worldwide, when the web records the order time, which time zone does it use, the server clock time is become irrelevant to analyze customer behavior. Another problem is non-integrated data. A particular business intelligence analysis might require data from an ERP system and a social networking application. Analysts may wish to integrate that organizational data with purchase consumer data. Such a data collection will likely have relationships that are not represented in primary key or foreign key relationship. It is the function of personnel in the data warehouse to somehow to integrate such data. Data can also have the wrong granularity, a term that refers to the level of detail represented by the data. Granularity can be too fine or too coarse. For too fine granularity, it is possible to capture the customer clicking behavior in what is termed clickstream data. Those data include everything the customer does at the website. For middle granularity are data for clicks on the news, email, instant chat, and weather check. All of that data may be useful for a study of consumer browsing behavior. It will be overwhelming if all we want to know is how customers respond to an ad located referently on the screen. To proceed, the data analysis must be throw away millions of clicks. Data can also be coarse. For example, a file of regional sales total cannot be used to investigate the sales in particular store in a region. And a total sales for a store cannot be used to determine the sales of particular item within a store. We need to find data that is fine enough for the lowest level report we want to produce. In general, it is better to have too fine a granularity than too coarse. If the granularity is too fine, the data can be made coarse by summing and combining. Only analyst labor and computer processing are required. If granularity is too coarse, then there is no way to separate the data into constituent parts. The final problem to have too much data. As shown in figure 9.13, we can have either too many attributes or too many data points. In other words, we can have too many columns or too many rows. In case of too many attributes, suppose we want to know the factor that influence how customers respond to a promotion. If we combine internal customer data with purchase customer data, we will have more than 100 different attributes to consider. A phenomenon called the curse of dimensionality. The more attributes there are, the easier it is to build a model that fits the sample data, but that is worthless as a predictor. There are other good reasons for reducing the number of attributes, and one of the major activities in data mining concern efficient and effective ways of selecting attributes. The second way to have an access of data is too many data points or too many rows of data. Suppose we want to analyze clickstream data on CNN.com. How many clicks does the site receive per month? million upon million. In order to meaningfully analyze such data, we need to reduce the amount of data. One good solution to this problem is statistical sampling. Organizations should not be reluctant to sample data in such situation. The data warehouse takes data from the data manufacturer, such as operational system and purchase data, cleans and processes the data, and locates the data on the shelf of data warehouse. The people who work with a data warehouse are expert at data management, data cleaning, data transformation, data relationship, and the like. However, they are not usually expert in a given business function. A data mart is a data collection, smaller than the data warehouse, has addresses the need of a particular department or functional area of the business. If the data warehouse is the distributor in supply chain, then data mart is like a retail store in a supply chain. Users in the data mart obtain data that pertain to a particular business function from data warehouse. They are knowledgeable analysts for a given business function. Figure 9.14 illustrates this relationship. The data warehouse takes data from the data producers and distributes the data to 3 data marts. One data mart is used to analyze clickstream data for the purpose of designing web pages. A second analysis store sales data and determine which product tend to be purchased together. The third data mart is used to analyze customer order data for the purpose of reducing labor for item picking from the warehouse. It is expensive to create, staff, and operate data warehouses and data marts. Only large organizations with deep pockets can afford to operate a system like that shown in Figure 9.11.